Sir, welcome, sir. Mohanraj, sir.
Yeah, thank you. Good evening, Lango.
Good evening, sir. Sir, our principal sir will join within a couple of minutes, sir. We'll start.
Okay.
Sir, Ganesh, sir.
Sir, good afternoon, sir.
Sir, good evening, sir. Manikandan, sir.
Sir.
Sir, principal sir joined.
Yes, sir. Kanishka, you can start.
Yes, sir. A pleasant evening, everyone. Success is where preparation and opportunity meet, so that our preparation and opportunity also meet together. On behalf of Department of Jubilee, SRM TRP Engineering College, I would like to welcome you all for the national level webinar on renewable energy technology, wind. Now I would like to call upon our HOD of Jubilee Department, Dr. P. Ilangovan, to welcome the gathering. Sir?
Thank you. Very good evening to one and all. I feel honored and privileged to get this opportunity to welcome all the dignitaries on this special day. I, on behalf of my colleagues and the entire SRM family, first of all spread my most sincere thanks to Almighty God. On behalf of the organizing committee of this event, I welcome our respected Principal Sir, Dr. B. Ganesh Babu, who gave his continuous guidance and blessings to organize this national level webinar on renewable energy technology, wind. The world is looking for alternate energy for fuel. We, the Electrical Society of SRM TRPEC, decided to bring up and share some recent renewable energy technologies to the young engineer minds. And as a result, we are here to execute this national level webinar with an eminent speaker, Engineer Mohanraj from Orient Green Power Company Limited, India. Now I welcome our chief guest of this session, Engineer Mohanraj, Head of Wind Power Plant Operation and Maintenance, Orient Green Power Company Limited, India, who gave us vital time from his busy schedule to grace this occasion. Then I welcome the participants from all over India, without whom this event is not at all possible. Last but not least, I welcome all the faculty members and students, especially from my TRPEC team, who structured this webinar. Once again, I welcome you all. Thank you.
Thank you, sir. Now I would like to invite our principal, Dr. B. Ganesh Babu, to felicitate the gathering. Sir?
Good evening, one and all present in this forum. It is my immense pleasure to welcome Thiru Mohanraj sir. Sir, welcome you for this forum on behalf of our management, SRM TRP Engineering College, and on behalf of our faculty members at TRPEC department, it is my duty to welcome you, sir. And once again, I welcome all the students. Good evening, student friends. It is a wonderful opportunity in your department. In many occasions, they are creating for you to learn so many things relevant to your, pertaining to your department core knowledge. So in this series, today you are going to have a very good lecture from the expert in the wind energy, renewable energy. So again and again, I need not to say about the importance of the renewable energy and what existing in India, what is going to be the future in India. Similarly, when we are talking about the EEE department, that is Electrical and Electronics Engineering department, we are always talking about the electrical energy and power plant engineering, environmental aspects, and so many things. But renewable energy is a very great resource, not yet depleted, not yet touched by our Indian engineers. So the few people are taking this as a passionate research area, and also they are working on it practically, like our chief guest. So he is the right person to reveal all his experience and share all his thought-provoking ideas to the budding engineers like you. Please utilize this opportunity. Have more discussion. If it is an interactive session, it will be well and good for your taking away points. So with these few words, I must appreciate the opportunity given by the department, make the opportunity with successful takeaway points. Wish you all the best. Thanks you once again for all the participants. Wish you all the best. Thank you, sir.
Thank you, sir, for your inspiring words. Let me introduce our chief guest. I feel extremely honored to introduce the chief guest and resource person of today's session, Mr. A. Mohanraj, EEE. His career started in the wind industry in year 2005 as engineer operation and maintenance in the company Enercon India Limited. He had 16 years of rich wind power plant operation and maintenance experience towards sustainable development. Currently, he is working in Orient Green Power Company Limited as head of wind power plant operation and maintenance. He is leading asset management of 425 megawatts wind power plant spread across the states of Tamil Nadu, Andhra Pradesh, Gujarat, and Karnataka. The above also includes a small 10.5 megawatts of wind farm in Croatia. Orient Green Power is the independent power producers of renewable power from wind and supplying power to various state government, electricity board, and private company. We hope that the people are able to seek guidance and imbibe something from his thoughts. Now I would like to hand over the session to our speaker. Sir, the session is yours.
Yeah, thank you, Mr. Ilongo, for a kind introduction, and thank you, beloved principal, and thanks, Ms. Kanisha, for a kind introduction of this session. Thank you all for joining this webinar. Thank you, students. Good evening to all. So are you able to see my slide, Ilongo?
Yes, sir. Yes, sir. Yes, sir. It is clear.
Yeah, okay. Thank you all. So today we are going to discuss about the renewable energy technology, so particularly the wind. Okay. Just this is introduction about our company. So Orient Green Power Company Limited is incorporated in year 2006 and it is listed in the exchange. The Orient Green Power is an independent renewable energy power producer which is located in Chennai So this Orient Green Power Limited is promoted by the Shriram Group, which has a diversified interest in financial and non-financial businesses. You know about the Shriram Group. There are a lot of Shriram Finances and Shriram Commercial Finances companies are all over in India. So they are the promoter of this group. And it is also backed up by the global private equity funds like Bessemer Venture Partners and Olympus Capitals. They are our partners who invested in our companies. The company has a portfolio stands at 425 megawatt of the wind energy. And we have the wind farms in 4 different states, which is majority of the wind farm is located in Tamil Nadu. So we have the 308 megawatt of wind farms in Tamil Nadu. And next to Andhra Pradesh, we have the 75.4 megawatt of wind farm. And third state, we have the Gujarat, 29.2 megawatt. And we have the smaller capacity in Karnataka, 1.25 megawatt. So total in India, we have the 414 megawatt of wind farms, which is operating in Orient Green Power Company Limited. And we have smaller capacity, which is located in Europe, in the country called the Croatia. We have the 10.5 megawatt. You can see the map of India map. So these are the 4 different states. We have the wind farm in operations. You can see that the red area and the different colors which is marked in the wind farm. These are the wind potential area which have the more than 200 to 250 wind power density watt per square meters. So currently around 7 to 8 states, the wind farms are in operation. And we also have the greater potential in Ladakh area. So in Ladakh, we don't have any wind turbines installed, but the central government is planning to install the renewable energy in Ladakh area also. Okay. So before we are going to in depth about the wind power, so we can touch the basics of the energy. So there are the types of energy. So energy that we can classify into the 2 different, one is a primary and another one is a secondary. So what is a primary energy? Primary energy refers to all types of energy extracted or captured directly from the natural resources. So whatever the energy which is capturing from the natural resources is called the primary energy. This primary energy we can divide into the another 2 different types. One is the non-renewable and another one is the renewable. What is non-renewable? Non-renewable is the energy which is coming from the fossil fuels like crude oil and its products, coal, natural gas, nuclear, etc. So what is called renewable energy? The energy which is capturing from wind, solar, biomass, tidal, geothermal, tidal, etc. So what is called secondary energy? So secondary energy, that is the primary energy is transformed in energy conversion process to more convenient form of energy such as electricity, steam, heat, etc. These form of energy are called secondary energy. So primary energy source are converted in industrial utilities in secondary energy source. For example, coal, oil or gas converted into steam and electricity. So what is non-renewable energy? So non-renewable energy is a natural source which can be produced, grown, replenished or used on a scale which can sustain its consumption rate. These resources often exist in a fixed amount or consumed much faster than nature can create them. So what are the fossil non-renewable energy? That is the fossil fuels, oil, coal, you see natural gas, nuclear. These are the non-renewable energy of non-renewable energy which is captured from the natural resources. But these natural resources such as coal, oil and natural gas take millions of years to form and cannot be replaced as fast as they are being consumed now. These sources will deplete with the time. You see the coal, oil and natural gases are very limited and most probably another 30 to 50 years it will get deplete. Further, regenerating of such sources is very critical. It will take the millions of years. So we are happily enjoying these resources, but if it get depletes, we need to go for the alternate energy. That is called the renew. That is another option is the renewable energy only. So which cannot deplete. It will be the part of our environment. So that is called the renewable energy. Renewable energy is the energy that is collected from the natural sources which are essentially inexhaustible. The most important features of renewable energy is that it can be harnessed without the release of harmful pollutants. So what are the renewable energy? You see solar, biomass, wind energy, geothermal, and hydropower. These are the renewable energy sources majorly using for electrical energy sectors to produce the power. So these are not harmful to the environment. So it is less harmful to the environment, which will not create more pollutions to the environment. Now we are facing a lot of climate changes in all over the world, as you are aware. So the next alternate is a renewable energy. To save the non-renewable energy sources for our future generations, so we need to look for the renewable. We need to look for the alternative of renewable energy also to avoid some climate changes and to avoid more pollutions, emission, to avoid more to avoid the emission factors. So we need to go for the renewable energy in upcoming days. Okay. So we see what are the types of energy. One is the renewable and non-renewable energy. So in renewable energy, there are a lot of natural resources are available. As I said in the previous slide, solars, biomass, hydel, wind, etc. So I was working in this wind sector for past 16 years. That's why I will go in depth on wind energy sectors. So wind energy is the kinetic energy of air in motion, also called wind. So wind, you can see it is naturally available in our environment. So the kinetic energy in the wind is converted into the mechanical energy, and then it is converted into the electric energy by using the wind turbine. The wind energy is a popular sustainable renewable energy source that has a much smaller impact on the environment compared to the burning fossil fuels. So as I said, wind turbine converts kinetic energy into the mechanical power to turn electric generators for electric powers. Okay, so how much energy can capture from the wind? So that is a theoretical formula for wind energy is 1/2 rho A VQ and time. What is a rho? Rho is the air density in kilogram per meter cubes. The air density can vary from surface to surface. So for normally in that sea, the air density is 1.14. For at ground surface, it will be 1.2 to 1.25. So V is the wind velocity or wind speed. It's the meter per second or kilometer per hour, etc. And A is the swept area of the wind we are capturing by the wind turbine, and T is the time. So this is theoretically we can capture the power from the wind. Okay. So next we are going to see about the Betts law. So this is the most important law in the wind energy sectors. So whatever the theoretically you are calculating in the energy from the previous slide, so it will not convert the exactly. To convert practically, we could not capture 100% of the wind energy from the environment. So that was proven by the Betts, Albert Betts. It was published in year 1919 by the German physicist Albert Betts. So what he is saying, the 1/2 rho VAV cube is a formula for the power. So if you get 100 watt of energy from the wind, by theoretically, but you can capture maximum of 59 watt only. Practically, it is possible only the 59 watts. So that was proved by the Betts law. According to the Betts law, so no wind turbine capture more than 59.3% of the kinetic energy in the wind. Okay, but in practically, you see the 75 to 80% of the Betts coefficient only we can capture the wind. That means so we are not touching up to 59%. Practically, at present days, we are capturing the power from the environment at 45% level only. So now the recent technologies with the improved aerodynamic efficiency of the blade, it is gone up to the 50%. Hopefully in upcoming days, with lot of R&Ds, it will go up to the 50 to 55% in the upcoming years to capture more energy from the wind. Okay, so what are the types of wind turbine? So there are mainly two types of the wind turbine. One is a horizontal axis wind turbine and another one is a vertical axis wind turbine. You see this this is a vertical axis wind turbine, and this is a horizontal axis wind turbine. So we can go in depth about vertical axis wind turbine and horizontal axis wind turbine in upcoming slides. But conventionally, practically, the horizontal axis wind turbines are most commercially used in the world globally, because there is some drawbacks in the vertical axis wind turbine to capture the power from the wind. Okay, what is vertical axis wind turbine? Vertical axis wind turbine is a type of wind turbine have the main rotor shaft arranged vertically and facing the wind vertically. You see, this is the rotor which is arranged vertically and facing the wind vertically. So that's why it is called the vertical axis wind turbine. But the vertical axis wind turbine produces less energy than horizontal axis wind turbine because it is mounted in the ground. Okay, so still produce power and can better option depending on the applications where we are using. So normally the vertical axis wind turbine can be used for pumping the waters or small power generations. It is also the micro wind turbines available in the market. The capacity is up to 1 kilowatt to 30 kilowatt. It can be mounted in the apartments or in the taller buildings. So they are more suitable where space is limited and come with a fewer challenge and risk to maintenance. The vertical axis wind turbine do not need to be pointed into the wind, which removes the need of wind sensing and orientation mechanism. So the wind direction can blow in any direction, so it will automatically capture because it was mounted, the rotor was mounted vertically to the wind flow. So there is no a lot of wind sensing equipments are available in the horizontal axis turbine, like anemometer. So anemometer is used for sensing the wind speed, and the wind vane is used for the sensing the wind directions. So that is not required for the vertical axis wind turbine. Since the wind turbines are lower on the ground, they do not harness higher wind speed often found at higher levels. If you see at the ground level, the wind speed will be, for example, if it is a 5 meter per second, when we go on higher side, if you go to about 10 meter from the ground level, the wind speed will be go 6 meter per second. At 20 meter per second, it will be 7 meter per second. At 100 meter, it will be the 12 meter per second. So exponentially, the wind speed will be in higher if you go above the ground levels. So vertical axis wind turbine cannot mount at the higher level from the ground. So that is the main drawback. That's why it is used for in the micro wind turbines with the capacity up to the 1 to 30 kilowatts. The next we are going to see about the horizontal axis wind turbine. The horizontal axis wind turbine is the most successfully and commercially, which is globally available in the market for generating power. So horizontal axis wind turbine is a type of wind turbine in which the axis of the rotor's rotation is parallel to the wind. You see, the rotor is parallel to the wind. That's why and it is located horizontal to the horizontal axis. That is why it is called the horizontal axis wind turbine. You see, the main rotor is shaft pointed to the wind direction to the extract power. The rotor receives energy from the wind and produces a torque on a slow speed shaft. Horizontal axis wind turbine, as I said, are the most common wind machines designed in uses today. Also, either it is a 2-blade or 3-bladed and operated high blade tip speeds. So 20 years before, the horizontal axis wind turbines are produced with the 2 blades, single blades, 2 blades, and in the single blade and 2 blades, there are a lot of centrifugal issues and a lot of gearboxes and mechanical issues are facing. That's why further it was developed to the 3 blades. You see various types of horizontal axis wind turbine. Previously it was a single blade, and then further it is converted to the 2 blade and 3 blade. Most commercially and conventionally 3 blade turbines are using in the market. And also the multi-blade turbines are available for pumping the water and also for a small scale application like agriculture and etc. And also another 2 types of wind turbines are available in the market. One is upwind and another is a downwind. You see, when the wind turbine is facing the wind direction, that is called the upwind. If it is facing opposite to the wind direction, that is called the downwind turbines. And also the another 2 types of wind turbines are available in the market. That is a gear and gearless wind turbine. So in the wind turbine, we are using the gearbox with generator, that is called the gear wind turbine, and another one turbine is called without the gearless, without the gearbox. It will directly connected, the rotor shaft is connected directly to the generator, that is called the gearless wind turbine. We can go in depth about the gear and gearless wind turbine in upcoming slides. Okay. So you see in this slide, you see the evaluation of wind turbine based on the power output. In 19th century, you see 1 to 12 kilowatt, which is multiple wind blades are available for generating the power. After that, in 1990s, it was gone up to the 500 kilowatt, that is called 0.5 megawatt. In India, the wind sector was started in between 1990 to 1995 with the 250 kilowatt turbine, that is called a 0.25 megawatt turbine, and 0.225 kilowatt turbine. And then it is gone up to now 3 megawatt. You see 1995, so it was 1.2 megawatt, it is introduced in the market. And then in 2000, it was gone up to 2 megawatt. Now 2005, 4 megawatt. And 2010, 7 megawatt. 2015, 9 megawatt. So at present in 2021, the General Electric, one company is called General Electric. That company was commercially, they are selling 12 megawatt wind turbine in 2021. And also the 16 megawatt wind turbine, which is a higher capacity, globally available in the market. The Chinese company Mingyang, who is installed the prototype of a 16 megawatt wind turbine. This turbine is located in the sea, that is offshore wind turbine. So there are a lot of research and developments are going in globally for evolving new technologies of the wind turbine and increasing the higher capacity. As you know, we need to go for alternate to the non-renewable energy sources because it is depleting in nature. So we need to go for the renewable energy source. There are a lot of renewable energy sources are available, like solar and wind. Wind markets are 80% of renewable energy source. Solar and wind are available because it is most cost competitive. So if you increasing the capacity by more research and development, then it will be have the more power productions to the countries, and we can save the climatic changes, and we can save our environment and the pollution which is caused by the non-renewable energy. You see, when the capacity of the turbine increases, the turbine height also, the horizontal axis wind turbine height also increases, because when we go higher height, the wind speed will be in higher side and more power we can get it capture. So currently almost 120 to 150 meters height of wind turbines is available commercially. But in India, we have installed with maximum capacity of 3 megawatt because we have a lot of logistical issues for transportation of blade. So when the higher capacity, we need to install, the blade length will be higher. So for transporting the blades on Indian road is a little bit difficult, but more and more the research and development is going on for the logistic front also. And the split blade means the blade has divided into the 3-4 splits. That R&D is also going on for transporting the blades in easiest way for installation of the higher capacity of the turbine. But at present 3 megawatt only the maximum capacity of wind turbines installed in India. Okay. The working principle of the horizontal axis wind turbine. So this is a cross view of the horizontal axis wind turbine. This is the wind turbine blade which is connected to the rotor, which is fixed in the rotor, and the rotor is connected to the gearbox. So the gearbox will convert the slow speed, higher torque into the high speed shaft to the wind generator. The high speed shaft is connected to the wind generator. In front, the slow speed shaft of the rotor is connected to the gearbox. Mainly the gearbox is converting the slow speed RPM to the higher speed RPM which is required by the generator. And then the generator rotates, it will convert the mechanical power to the electrical power, which is pumped to the grid. And from grid, it is delivering the power to the various consumers. And this is the anemometer as explained to you. This is the sensor which is sensing the wind speed of the wind turbine. And this is the wind van, which is used for this wind turbine to align to the wind directions. And this is the blade, and the blade will be the rotating, rotate from 0 to 90 degree. So when the turbine is at standstill, there is no any generation, then the blade will be at the 80 to 90 degree. It is shifting to the 80 to 90 degree. It will pass on the wind. It will not capture the wind to convert the kinetic energy into the mechanical energy. So during a standstill or any faults in the wind turbine. So that process is called pitching. That process is called pitching. And another one process is called the yawing. As I said, the wind direction is not unique. The wind direction will change from any direction, north to south, south to west, west to east, any direction the wind blows. But mostly during the high wind season, normally the southwest from between the May to September in high wind potential area, the wind will flow from between the southwest. Okay, so the wind direction will change. To align the wind direction, we need the yawing process. The entire wind turbine will move by using the gears. That process is called yawing. For yawing, we need the yaw drives and the yaw motor. So the yaw motor will rotate based on the wind van sensing, wind van sensors. So wind depends upon the wind van sensors, automatically it will align to the wind directions. So this is the common working principles of the horizontal axis wind turbine. Okay. So what are the parts of horizontal axis wind turbine? So there are mainly 6 different parts. So the major 6 different parts of horizontal axis wind turbine. The first one is a tower. This is a tower, and this portion is called the nozzle. So it is nothing but a housing for the drive train. That is a generator and gearbox drive train. That is called the drive train, which is located in the housing. That is called the nozzle. And the next is the rotor with the blades. So the rotor with the blades. The blade is fixed in the rotor. It is also called the inner part is called the hub, which is connected to the gearbox. And the next one is the foundation. The tower is fixed in the foundation. Normally the foundation, we can go in depth about the foundation also. As I said, the generator and gearbox, which is called the drive train for generating, for conversion of kinetic energy into mechanical energy, and further it is converted to the electrical energy. And the third one, sixth one is a transformer, which is located at the bottom of the wind turbine, but the new technology turbines which are located top of the nozzle also. This transformer, it will go the function of the transformer also in the upcoming slides. First, so we are going to see about the tower of the wind turbine. that carries the nozzle and the rotor. So nozzle is the housing of the drivetrain. That is a gearbox and generators and other auxiliary parts like yawing, yaw motors, and the brake systems. And there are a lot of electronics items are there for controlling the wind turbine. So which are located in the nozzle housing. So normally these nozzles and the rotor are carried by the towers. The towers for the large wind turbines may be either tubular or tubular steel towers, lattice towers, or concrete towers, and hybrid towers. There are 4 different types of towers are available in the market for commercial wind turbines. So inside the tubular tower and the lattice tower also, we have the ladder for accessing the nozzle for maintenance activity, for installations, and for replacement of various components during the operation process. Okay, and this is a lattice tower. This is a tubular tower. The tubular tower are 2 different types. One is a steel, which is made of steel, and another one is a concrete. Now, for past 5 to 10 years, to avoid import of the steels and steel steel cost are huge variations. To control the cost, now the concrete towers are also available. And also now the recent days for a higher height of the wind turbine, the mix of hybrid that is called the lattice and tubular, both are available in the same tower. So that is called the hybrid tower. So inside the tubular tower and lattice tower, there will be the ladder is available for accessing the nozzle and the rotor for maintenance activities. And the next one is a nozzle. The nozzle of the wind turbine houses the drivetrain, that is a gearbox and generator, and other tower top components. Other components means, as I said, the hydraulic brakes, converters, yaw systems, yaw bearings. So most of the auxiliary components are located in the nozzle. So the nozzle is a very strong hollow shells that contains the inner working of the wind turbine. So it is a very hollow shells. It's like square shape or hollow shapes. So we can do maintenance activities also. There is a platform available in the nozzle. It sits on the yaw bearing. You see here at top of the tower, there is a yaw bearing. And the yaw bearing, this entire nozzle will sit. So as I said, for aligning to the wind direction, the yaw bearing will rotate by using the yaw motor for capturing more power from the wind. If the entire nozzle is not aligned to the wind direction, then we could not capture more power. That's why the yawing is required for aligning to the wind. So the nozzle can be accessible for maintenance and repair work, access usually via the lift and ladders within the tower. You see, in previous days, 10-15 years back, the height of the tower, wind turbine tower, is between 30 to 50 meters. We can easily climb the tower for maintenance activities, but nowadays more than 100 meters are available. For climbing 100 meters is very difficult for the accessing the nozzle, and also the huge impact on the manpower, and it will also take the lot of efforts and lot of manpower efficiencies. So nowadays the lifts are available in the tower itself. We can easily go to top of the nozzle for maintenance activities, troubleshootings, breakdowns, and preventive maintenance, predictive maintenance. For that purpose, you can easily access the lift, and also we can save the time also. So this nozzle usually it is made up of the fiberglass. Mostly 95% of wind turbines mostly use the fiberglass shells. But in some cases, some turbine manufacturers are using the steel also. But if you use the steel, then the weight of the nozzle also a little bit heavier. So that's why they are going for the fiberglass. It is a lighter weight, and almost we can reduce the 1/3 of the weight. Next, the rotor with blades. We saw earlier two tower and nozzle, and third one is a rotor with blades. The rotor which connects to the generator either directly or through a shaft and a series of gears that speed up the rotation and allow for a physically smaller generators. Okay, the rotor, you see this rotor is fitted with the blades, and further it is connected to the rotor shaft is connected to either to the gearbox or to the generator directly. That is a geared wind turbine generator. It is connected to the gearbox. If it is a gearless direct drive one, it will directly connected to the generator. This translation of aerodynamic force to rotation of a generator creates electricity. This rotor is a major function. As I said, according to the Bird's law, we can capture 59.3% of the wind energy from the wind, not 100%. But as I said, practically, currently the commercial wind turbines max of 45% only. But some turbine manufacturers are claiming 50% of wind energy can capture. But it's all depends upon these rotors and the blade profile. That is called the aerodynamic efficiency of the blade. Mostly, if the efficiency of the blade is so high, then it will be lift and drag force will be high. Then it will capture more kinetic energy, and further it will convert to the mechanical energy for converting to the electricity. So these wind turbine rotor blades are made up of glass fiber or carbon fiber reinforced composites. In earlier days, older days, it is made up of wood. Those days, the glass fibers are not so much familiar in the industries. So in those days, the wooden blades are used for the smaller capacity of the wind turbines. And now they went to the carbon fiber. The carbon fibers are used in the aeroplane wings and all. It is a very less weight. If you reduce the less weight, we can capture the more power from the wind. And we can we can reach up to the 55 to 59.3 megawatt, 3% of the theoretical calculations of according to the Betz law. That's why a lot of research and developments are going on the blade and the blade, how to improve the blade efficiency, how to improve the aerodynamic efficiency of the blades. And slowly year on year, there are improved blades are available in the market by using the carbon fibers, etc. So rotor with the blade is used to conversion, as I said, the kinetic energy to the mechanical energy. And okay, next one is the foundations. Tower, we saw tower, nozzle and rotor with the blades. Okay, so the tower, on top of the tower, nozzle with rotor and blades are located, and the tower is mounted in the foundation. The main task of foundation of wind turbine is that it can transfer and spreads the load to the soil at depth. Okay, so the lot of wind blows can transfer the load to the rotor, and further load transfer to the gearbox and to the generator and to the tower. The entire load transfer to the ground is through these foundations. The vertical and horizontal forces which acts on the turbine foundation are due to the self-height of the wind turbine and wind respectively. The foundation are made up of steel reinforced concretes. You see, the lot of steel and reinforced concretes are used for the foundations, and further there are mounting bolts are available. The tower can be erected in the mounting bolts, and it can be bolted by using the bolts. The size of the foundations varies, depends upon the capacity of the turbine. So normally the 250 kilowatt turbine, that is a 0.25 megawatt wind turbine, normally the foundation will be between the dia of 3 meter to 4 meter. But if you go to 1 megawatt, 5 megawatt wind turbine, then the diameter of the foundation will increase around 10 to 20 meters. Okay, so next, the gearbox and the gear wind turbine. This gearbox is converting the kinetic energy into the slow speed high torque wind turbine rotation to the higher speed required by the generator to generate electricity. In wind turbines, next slide we are going to see the generator also. The induction generator is used to generate the electricity. So for induction generator, for 4-pole or 6-pole generator, the 4-pole generator, synchronous speed is 1500 RPM. We could not connect directly to the rotor shaft because the rotor shaft, the RPM of the blade is between 10 to 30 meter per second. Depends upon the capacity, it will vary. If it is higher capacity, the RPM is very low. So to convert the slow speed, high torque to the 1550, 1500 RPM, for that purpose only we are using the gearbox. Okay, so most 80% of the wind turbines available in the market are the gear wind turbine. Nowadays, the gearless wind turbines are very popular, and the population wise, it is very less as compared to the gear wind turbine. But in upcoming days, it will increase day by day because there are a lot of advantages are there. There is no any wear and tear on gearbox. Replacement of gearbox is taking a huge time, and we need to arrange heavier equipment like a crane and other parts. So it will avoid if you go for the direct drive turbine, that is called the gearless wind turbines. So conventional wind turbine often uses the 2 to 3 stage gearboxes. The first one is the planetary sections. Mostly the mechanical students know about the planetary, what is a planetary, what is the benefit of the planetary stage. And the next stage is called the helical. This helical is a 2-stage, and further this is the output shaft. This is the input shaft, which is connected to the rotor with the blades, and further it is connected to the planetary section. After that, there is a 2-stage of helical stage, which can convert the slow speed to the high speed for generating power. So this is the gearbox. This is the 500 kilowatt gearbox turbine. So this is the input shaft, slow speed input shaft. This shaft is connected to the rotor with the blades, and this shaft is connected to the generator. This is actually this is the brake disc. For in case of any breakdowns or any preventive maintenance, we need to use this hydraulic brake system. There is a hydraulic cylinder is available for braking of the wind turbines. This is a brake disc. You see in most of the two-wheelers are available now. The same operation is in the wind turbine also. And the next is a generator. The generator converts mechanical energy to the electrical energy. So as I said, the induction generator is the most popular in the wind turbines. 80% the induction generators are using. And another one is the permanent magnet synchronous generator. This permanent magnet synchronous generator is used for the direct drive turbine. So the rotor is directly connected to the wind turbine. And the third one is the field excited synchronous generator. The rotor have the field winding, which can be which can give the excitation. Excitation voltage is required. Excitation power is required for generating the power. So in permanent magnet, you know, the permanent magnet that it is not necessary to give excitations. So the gear wind generators, when the induction motor and the generator is same. Initially, the wind turbine will act as will run as a motoring mode before generation. So when the speed crosses the synchronous speed, it will automatically pump the power to the grid because of the negative slip. So on that concept, the induction generator is working. So when initially when the turbine starts, it will consume power from the grid for a fraction of minutes, 1 to 2 minutes. After that, if the turbine goes above the synchronous speed because of wind, because of mechanical power, then it will automatically pump the power to the grid. There is no any interface required for the induction generator, but you see this is the induction generator, and this is a direct drive permanent magnet synchronous generator or field excited generator. And the outer part is a stator, and the inner part is a rotor. The rotor is normally permanent magnet, or maybe the excitation, field winding. Okay, so as I said, the gearless wind generator, low speed synchronous generator with no direct grid coupling. Because, as I said, the induction generator will directly couple to the grid without any conversion, because it will generate power which is matching to the grid. For example, 440 volt and 50 hertz, it will automatically pump to the grid. For direct drive generator, it will not. It will generate the variable voltage. So it will generate variable alternating current voltage, and the frequency is also variable. So we need to convert this variable voltage to the DC direct current, and then further it is converted to the fixed alternating current and fixed frequency to pump to the grid. So in a direct drive train, the lot of interfaces are required. We can see about in detail in upcoming slides. So the last one is a transformer. The transformer acts as a link between the wind turbine and the distribution grid. So this is the interface. You know about the transformer. There are two different types of transformer available: step up and step down. So if you want to down the voltage, it is called the step down transformer. If you want to increase the voltage, it's called the step up. So normally in wind turbine, the generator will generate the voltage between 440 volt. 440 volt generator is also available, and 690 volt is also available. For higher wind turbine, 690 volts are available. So we could not synchronize to the grid 690 volt to the grid, and we cannot pump low voltage power to the long distance. So that's why we need to step up the voltage. For that purpose, step-up transformer is used in the wind turbine. Normally, it is mounted in bottom of the wind turbine, but in recent days, to avoid the transmission losses between nozzle to bottom, so they are mounted at the top of the nozzle itself. So that 33 kV or 11 kV or 33 kV, 66 kV cable will goes up to nozzle to avoid transmission losses. Because when the low voltage, when it is the voltage is very low, then the current will be high. If it is the current is high, then the copper loss of the cable is so high. So to reduce the current, you need to increase the voltage. For that purpose only we are using the transformer. So as I said, it can be located near the tower base, and the recent technology turbine is located in the nozzle itself to avoid the transmission loss. So we saw 6 different parts of the major parts of the wind turbine. The first one is the tower, and the second one is the rotor with blades and nozzle and gearbox and generator and transformer. So here working principle of the gear wind turbine, as I explained to you all before itself. So this wind rotor is connected to the gearbox, and further it is connected to the generator. So normally in gear wind turbines, induction generator and the double fed induction generator is used. Double fed induction generator means the rotor will be, wounded rotor will be used for increasing the negative slip, and also the power available in the rotor is also captured by the grid, and the losses in the rotor is also capturing to the grid and the recent new technology machines. So the induction generator will automatically synchronize to the grid when it is a negative slip, when it is goes above the synchronous speed. So this capacitor bank is used for managing the reactive powers which is generating by the wind turbines. You see, it is a grid. Further, it is connected to the grid transformer, and further there are switch gears are available like circuit breakers, SF6 breakers, vacuum circuit breakers are available for isolating in case of any faults. In case of any faults in the grid, it will get isolated to the grid. So the next one is a gearless wind turbine. It is the most popular wind turbines nowadays because it eliminates the gearbox. So gearless wind turbine eliminates the gearbox. Instead, the rotor shaft is attached directly to the generator, which spins at the same speed as its blades. That is, rotor normally rotates at the slow speed. Now it directly connected to the generator. Then the generator also rotates the slow speed. If it is speed is slow, then the induced voltage in the generator is also low, and it will not be the sinusoidal form, and the variable voltage will be, variable frequency will be there. So for that, to convert to the fixed voltage, we need to have so much converters that we can see in the next slide also. The most preferred direct drive wind turbine generators are the permanent magnet type generator, as it is a lighter wind weight. Because of the weight is very low, that's why the most preferring is the permanent magnet in the wind industries. You see, I have told you that this is the blade which is mounted. This is a cross section of the direct drive turbine. This is the blade mounted in the hub and the rotor, and this is a pitch motor, so which can rotate the blade from 90 degree to the 0 degree. So when the turbine is in operation, the blade is in 90 degree. When the turbine is in running mode, it is in 0 to 1 degree. For that purpose, the pitch motor is used, which is controlled by the program logic controllers, PLCs, microprocessor, etc. This pitch motor is normally the direct drive series motor, because in case of the grid failure, we need to brake the wind turbines. There are two types of brakings are available. One is the aerodynamic braking, and another one is a mechanical braking. This pitching operation is called the aerodynamic braking. So this DC series motor is connected to the battery. When the grid goes off or any malfunctions in the wind turbine, automatically the battery will operate the pitch motor, and the blade will rotate to the 90 degree. If it is in 90 degree position, the wind automatically passes away from the rotor. The rotor will not capture the kinetic energy from the wind. That is called the pitching operations. And this is called the yawing operation. These two motors are called the yaw motor, which can align to the wind direction. Yawing for yaw, which will rotate the yaw bearing, and based on the wind band signal, it will operate. You see the cross section of the wind turbine. This is the rotor, and this is the hub, which is mounted. Blades are mounted in this hub, and this is the excited rotor. Actually, this manufacturer is excited rotors are using, and the field windings are available in the rotor. And this is a stator winding. Further, it is connected to transformer through cable, and there are a lot of electronics equipments are available for controlling the wind turbines, for controlling the braking. One, as I said, the pitching operation is required. The pitching operation is doing the aerodynamic braking, and another one is the mechanical braking. Normally, the mechanical braking using the hydraulic motors. You see a lot of cars and two-wheelers, their disc brakings are using. So the hydraulic pressure will apply into the braking shoes. Automatically, the turbine will goes off. For that purpose, there are a lot of electronics controllers are available in the nozzle. So this is the cross section of the nozzle, which is shaped like a egg shape, and some manufacturers are using rectangular shape. Some of them are conical shape. The manufacturer to manufacturer, the nozzle shapes are will get differ. And also, this is a slip ring. Slip ring, the slip ring is used to transfer any electrical signal from rotating part to the fixed part. So in case of any for pitching operation, this rotor will rotate. For that purpose, the electrical power from battery from the fixed nozzle to the rotating portions by using the slip ring. So this is a single line diagram of the direct drive turbine. You see in gear wind turbine, it is directly synchronized to the grid, because if we are using the induction generator, if it goes above the synchronous speed, it will automatically sync to the grid voltage and grid frequency. But in gearless wind turbine, so we need a lot of conversions are required, and also it will be the light in weight. If it is light in weight, we can capture more power from the wind. So if it is a gear wind turbine, if you are capturing at 40% according to the bid, 40% of the energy from the wind, but in the direct drive turbine, it will goes up to the 45 to 50. So that's why in recent technology, mostly preferring the direct wind turbine, but it needs a lot of electronic component for conversion. You see, this is the rotor, and this is a permanent magnet wind generator or excited rotor generators are using in the direct wind turbine. Further, there is one circuit breaker for production of this generator, and then there is a generator side, there is a converter is available. So this converter will convert the variable alternating current voltage and variable frequency voltage to the variable direct current. Okay, so variable direct current. So this is a rectifier. Normally it is called as the rectifier. So which converts alternating current to the direct current. But the alternating current which is generated by the direct drive turbine is a variable in nature, and it is converted to the variable DC. Further, the DC choppers are using step-up choppers, step-down choppers you studied in the power electronics subject. This step-up choppers will further increase the voltage which is required for the grid level. So okay, this variable further this chopper is convert variable DC direct current to the fixed DC, and the fixed DC is connected to the voltage source inverter, and the voltage source inverter will convert the fixed DC to the fixed alternating current with the frequency of 50 Hertz. In European and some countries 60 Hertz are using. So that's why these converters required for conversion of variable power to the fixed power to synchronize to the grid. So for that, there are a lot of converter controls are required to control the rectifier, to control the choppers, to control the voltage source inverters. We need a lot of program logic control, PLCs, microprocessors using. Okay, and further, this I told you this pitch drive which is used for the aerodynamic braking, and also the mechanical brakings are available for controlling the wind turbine. Okay, so what is called wind farm? So wind farm as a group of wind turbine is called the wind farm. So in a wind farm, there are multiple wind turbines are connected to the state electricity board substation. For example, if you see this single line diagram, there's a 4 wind turbines are connected to the maybe 11 kV or 33 kV or 66 kV lines, and it is further connected to the state electricity board substation or private electricity substation, so which can further convert to the higher level. Further, it means 11 kV to the 33 kV. So if you want to transfer the power from Kanyakumari to Chennai, then it will, if you transfer the power at 33 or 111 or the 66 kV level, the transmission loss will be more. That's why we need to step up the voltage. For that purpose, the substations are using. So further, this 33 kV, 22 kV, 11 kV, 66 kV is converted to the 110 kV, 230 kV. Nowadays, the 400 kVs are available to transfer the power to the various part of state and various part of countries. And then further, it is come to the from Kanyakumari to Chennai. It will come, and here the substation will be available by the TNEB. Further, it is stepped down to the 33 kV level or 11 kV or 22 kV level. Further, it is distributed to the 230 volt AC, 440 volt AC. And for the industries, 11 kVs are using, 33 kVs are using. So further, it is stepped down to the voltage, and further it is going to the consumer. So this is the how the power flows from the wind farm to the consumer. This is the outline, a single line diagram. So the group of wind turbine is called the wind farm. Okay. So next, you see, in our company we have the 425 megawatt of wind turbines, which is equal to the 640 wind turbines. So there are 640 wind turbines are located various part of country, and also we have internationally we have small capacity in Croatia. Okay, so how we need to monitor the wind turbines? So there we are using the SCADA. SCADA, I think you studied about the SCADA. SCADA, the expansion of the SCADA is the supervisory control and data acquisition system. So we can control the wind turbine by using the SCADA, and also we can acquire the data from the wind turbine. So normally the SCADA is a computer-based system that allows local and remote control of a basic wind turbine functions. I have the SCADA system in our companies for 300 megawatt of wind turbines. We have the 24/7 monitoring station in Chennai head office. So we can easily control the wind turbine. I can switch off the turbine, I can switch on the wind turbines from Chennai itself. So I can troubleshoot the wind turbine. So what goes wrong in the wind turbine, we can see the various parameters of the wind turbines in Chennai itself. That's why that is the purpose we are using the SCADA. Also, it collects the data from the wind farm. There are n number of data are available in the wind turbines. For example, basically the wind speed, wind directions, and power, voltage, current, what is the temperature, ambient temperature. The wind blows because of the variation of the heats in the heat waves between the sea and ground level. So the ambient temperature is the most vital factors of the wind velocities. And also how much powers which is we are pumping to the grids, everything we can monitor from the SCADA system. So it collects data from the wind that can be used to analyze and report on the operational purpose. You see, this is an example dashboard of SCADA. So we have near Tuticorin, we have the name called Epodumendran. So we have 17 turbines of 1.8 megawatt wind turbines. So which is total 5.9 megawatt, which is generating at a wind speed of 5.7 meter per second. So we can easily visualize the performance of the wind turbine by using the SCADA systems. And this is the onshore and offshore wind farm in India. We don't have offshore wind farm, but the central government proposed, and there are a lot of studies are going on in Rameshwaram and in the Gujarat state in Kutch area. Most probably in upcoming days, 1 or 2 years, the offshore wind farm is also installed in India. In Europe and US, a lot of offshore wind farms are available for harnessing the wind. So, which is onshore wind farm, which is mounted in the ground. Okay. And what is the merits and demerits of the wind farm? I think I've taken a lot of times. 2-3 slides are there. I will go fast. merits, there is no emissions, and there is the carbon footprints, lower carbon footprints, and reduces harmful air pollutants, use less water, and benefits to the economy. So how it benefits to the economy? Importing of the fuels, importing of petrols, importing the crude oil, it will eliminate it. So on that way, it will benefit to the economy. And there are demerits also in the wind energy sector. The renewable energy are considered the infime. The wind blows and the environment is depends upon the heat and depends upon the season. Normally in India, in Tamil Nadu, between May to September is the high wind season, and from October to March, the wind speed will not be so high to generate power. The 80% of the wind generation will capture between May to September. So that's why it is called the infime, and difficult to supply the round-the-clock power. So we could not, the wind speed blow and the environment is always not constant. It will vary. Sometimes in the evening it will be high, in the night it will be low. So that's why it is very variable in nature. That is the main drawback. And also the seasonal, we can capture the power between the May to October. And this is the plant load factor. I think you studied in the power plant engineering. What is the plant load factor? We can maximum 1 megawatt of turbine. It will capture up to 18% of 35% of plant load capacity in a year. Okay, and the next is the carbon emissions. So the carbon emissions, the high pollutions created by the industries are the 51% are mainly the electricity generation and heat producers. Some industries require the heat productions. So the electricity and heat production is the mainly contributing, 51% is contributing to the pollutions. Okay, and for per kilowatt hour per unit, you say the per unit is polluting 0.91 to 0.95 kg of carbon dioxide in the carbon emissions in the environment. So, and the next is the industry. 24.7% is the industries and 13.2% is the transport and other sectors. And you see the lot of various discussions are going on by the Ministry of Government, Ministry of Powers. The e-vehicles are promoted, but if you are promoting the e-vehicles, but the charging of the e-vehicle has to be done by the renewable energy, then only we can eliminate the carbon emissions. If diesel vehicle and the petrol vehicles are polluting the environment, if you go for the electric vehicle, then if you consume power from the thermal or any non-renewable source, then the pollution will goes to the another sector. So it will not solve the problem. So for charging the e-vehicle, you need to ensure the renewable source has to be used. So that's why we are pushing the government to promote renewable energy like solar and wind for protecting our environment. At Orient Green Power, we are reducing carbon emissions by 7 to 7.5 lakhs tons of tons in a year through wind generation, which is equivalent to about 60,000 tons of oil. So we are saving 60,000 tons of oil by using the wind energy, by using the generation of wind energy. And in Tamil Nadu state, about 10,700 million units are generated from the wind energy. Out of in a year in 2020, the 1,03,474 million units the consumption of the entire state. In that, around 10% are from wind energy. So, okay, so these are the wind turbine installed capacity in various states. Tamil Nadu leads at 9,608 megawatt, and then Gujarat and Maharashtra. These are the top three wind installed capacity all over the India. The total wind capacity is 39,247 megawatt. And you see the total installed capacity of power sector is 3,86,888 megawatt. Out of this, 98,883 megawatt is from renewable source, small hydro project, biomass, wind and solar, etc. So 25% are installed capacities from renewable source, which can increase day by day. And we have the potential of 6,095 gigawatt of a potential at 120 meter ground level. Wind energy potential in India, we can increase rapidly for entire India's requirement of wind energy in upcoming days by using the renewable energy source. So these are our the wind farm photographs, which is located in the south part of the Tamil Nadu in Thoothukudi, Tirunelveli, and Nagarkoil and Udumalpet in Coimbatore regions, in particular in Tamil Nadu. And these are the insides wind turbine. This is the gearbox, and this is the further connected to the generator. This is the generator. This is the brake disc for braking operations. So this is a winch for lifting the materials. So we can do the work maintenance activity in this platform, nozzle platforms. So these are the sensor anemometers, wind van, which is located top of the nozzle. And this is the synchronizing equipment power converters, which is available in bottom of the wind turbine. The wind technician is climbing to the turbine for the maintenance activities. Okay, thank you.
Thank you, sir, for providing us with this wonderful and informative session. Students, if you have any queries, unmute yourself and interact with the speaker, or else post your questions in the chat box.
Yeah.
Sir, actually, someone has posted some questions. Shall I read, sir?
Yeah. What are the challenge we have faced when we are using wind power plant? As I said, the wind power plant is infirm in nature. The state load dispatching center, they are managing the power demand and supply of power. They are managing the, if the demand is there, we need to get supply from the power generating station. But in the wind power plant, we could not increase the power or decrease the, we can able to decrease the power, but we could not increase the power because wind is uncontrollable, it is infirm. So that is the main challenge. But to face the challenge, we have forecasting and scheduling mechanism. So there are a lot of resources are available. We can forecast the climate. You see, the Indian Meteorological Department is forecasting the climate, when the rain comes, how much wind will blow. So those factors we are calculating a day ahead, and we are giving to the state load dispatch center for managing the demand and generation gap. But there are a lot of challenges there, but we are working as a wind industry. We are working very closely with the state load dispatching center to infuse the more wind power to the grid. And why double fed induction generator used mostly in wind turbines? And one question is there, because the double fed induction generator, you know the caged rotors. The caged rotors will have some losses, okay, copper losses, and it will generate heat also, you know very well. So to capture those energy also from the rotor, whatever the energy losses in the rotor, we can capture, but the losses, the generating voltage, the voltage power available is a variable in nature in the rotor that can be converted by using the rectifiers and inverters. So we can capture more power from the double fed induction generator. That's why DFAGs are using. I think why we can't reach more than 45% efficiency in wind power plant. Yes, it is a good question. As I said, Betts law, according to the Betts law, theoretically it is a 59.3% is proven by the Betts, Albert Betts. But you see, there are a lot of transmission losses that there. First, you are converting from kinetic energy to the mechanical power. So if during that conversion, any conversion will have the transmission losses, okay? And mechanical energy to the electrical energy. Further, electrical energy is pumped to the grid. So there are 2-3 stages are there. Each stage have the transmission losses. That's why we are not able to capture up to 59.3%. But by improving the efficiency of the blades, improving the efficiency of the gearbox, improving the efficiency of the generators, this efficiency can be improved. But a lot of research and developments are going on to achieve 59.3%. But recently some turbine manufacturers are claiming they are able to achieve up to 50% of the efficiency. Yeah, what is the cost per unit? Say the cost per unit, the wind is free, okay? There is no any, if you go for the thermal plant, you need to buy the coal, lignite, etc. That is a cost. But the input fuel of the wind turbine is free of cost. But you have the operational cost like gearbox maintenance, and you need to have monitor the turbines. The operational costs are there, and you have the capital cost also. Normally, the cost per unit is between 7 paise. The production cost is between 70 paise to 1 rupee. It depends upon the wind potentials available in the site. The site to site, the wind potential varies, and then cost per kilowatt hour also vary. that is 70 paise to 1 paise, 70 paise to 1 rupees. So what are the major faults which occur in the double-fed induction generator based wind turbines? There is no any major fault. They have the good technology. I think European is the leading wind turbine technology. We are transfer the technology mostly from Europe to India. There are a lot of development is required in India also. So the young champs, you students, you have to more research and development has to be done in this industry for protecting our environment, to save the non-conventional, non-renewable sources for our future generations. So, but the ministry has the indigenous government body, the name called NIVE, the National Indian Wind Energy. It is a government body. They are doing a lot of research and development in these wind sectors. There is no any major fault on DFAGs. And but windmill need more place. How it was managed? You see, 1 megawatt wind turbine required 3 to 4 acres of land. Not much as compared to the solar. Solar needs huge land. Contiguous land is required. For wind, we can install like it's like a tree. We can install it in some few distances. That is called micro sightings. It is a huge in-depth topics. So we can. There is no much land is required. So how to manage the noise produced by the windmills? You see, the IEC codes are available for the wind turbine manufacturing, and normally the wind turbine noise is between 60 to 70 decibels. It will generate the full load capacity if it is running. There is also noise curtailment is there. For example, in Europe, under the laws are very stringent. If the wind turbine creates more noise, the nearby homes will file the cases. For that purpose, if the noise goes above such a level, it automatically curtails the power from the wind. There are a lot of automatic technologies are available in the wind turbine. And also there is a shadow curtailment is also there, because in Europe and all, very rare the sunlights will come. During that time, the blade rotates, means the blade shadows will fall on the windows of the home. It will disturb the neighbors. So also for controlling the shadow, we have the shadow shut-off available in the wind turbines. There are a lot of new technologies are available for managing the various difficulties as we are facing in the renewable energy sectors. Yeah, thank you. I took a lot of time to explain about the wind energy. I think 20 minutes taken more. Thank you for your patience. So if you have any questions, I think there is no any question.
Thank you, sir. Thank you very much.
Yeah, thank you.
Thank you very much, sir.
Thank you, sir. Now I call upon our third year student, Gracie Merlin, to deliver the vote of thanks.
Good evening to one and all present here. It is such an honor for me to get this opportunity to propose the vote of thanks to all dignitaries. On behalf of Tribly Department, SRM TRP Engineering College, I extend my sincere thanks to all the people in the gathering. I would like to express my gratitude to all esteemed delegates of this national webinar for their presence and contribution for making this webinar a resounding success. I extend my deepest sense of gratitude to our resource person, Mr. A. Mohanraj, Head of Wind Power Plant Operation and Maintenance in Orient Green Power Company Limited, India, who spared time from his busiest schedule to grace this occasion. It was a great opportunity for us to hear your thoughts, sir. You enlightened us with your knowledge. Thank you, sir. A special thanks to our Honorable Chairman, Dr. S. Shivkumar, sir, for his continuous support and motivation. I would like to thank our principal, Dr. B. Ganesh Babu, sir, for providing immense support for making this webinar successful. Thank you, sir. I extend my gratitude to our HOD of Tribly Department, Dr. P. Ilangovan, sir, for organizing a webinar even amidst this pandemic. Thank you, sir. My heartfelt thanks to the faculty members who has always been our guidance. Last but not the least, I would like to thank all the participants for your valuable presence. Gratitude makes a sense of your past, brings peace for today and creates a vision for tomorrow, said by Melody Betty. Once again, I thank you all for your participation. Thank you.
Thank you, Gracie Melvin. Feedback link will be posted in the chat. Students kindly fill the feedback link to get a certificate. Thank you all participants for making this event a success. Thank you.
Yeah, thank you all. Thank you, Mr. Ilango, Principal, and the entire team of SRM Engineering College, TRP Engineering College. Thank you.
Thank you, sir. Thank you very much, sir.